In this video, we're going to review some basic and some new circle vocabulary. To first review some basic vocabulary here, we have a circle. And a circle will be any set of points that are equidistant from a fixed point called a center. So in this green circle here, my center point would be this point. And this set of points equidistant from the circle will form the outside of my circle. Now, two terms that go along with the circle will be our radius and our diameter. Our radius is going to be from the center of the circle to any point on the circle. So going from the center to the edge would complete a radius. Now, it doesn't matter where I draw this radius, all radii are congruent to each other. The diameter is going to be a segment that goes from one side of the circle and passes through the center and continues on to the opposite side of the circle. So my yellow line there would be a diameter. The radius is equal to half of the diameter, or as shown here, that the diameter is equal to 2 times the length of the radius. Now, when we talk about points on a circle, we can talk about points that are going to be either inside the circle as an interior point like point E, or an exterior point like point D. This will become important when we start to talk about solving problems and we have segments or chords intersecting. Important formulas that we already know about circles. The first one's going to be our circumference formula. And circumference is going to be kind of the perimeter of the circle, which is the distance around the circle. So circumference is equal to pi d. The area will represent our shaded portion. So this green shaded portion that we have here, the entire inside of the circle, that's going to be our area, which is area is equal to pi r squared. Moving into some new vocabulary here, our first term is going to be a central angle. Now, a central angle is going to be an angle whose vertex, remember the point of the angle, is at the center of the circle. So we can see here that angle BOA is a central angle. And we know it's a central angle because its vertex is at point O, the center of our circle. We have two different types of arcs here. We have what's called a minor arc, and then we have what's called a major arc. And this is all going to be in relationship to the size of the arc, kind of like what we think of as an obtuse angle or an acute angle. So if we have a minor arc, it's going to be an arc that is going to be less than 180 degrees. In written words, we would say minor arc AB, or we can start to represent symbols, arcs with symbols. Now this one's a little bit off, but I could also do it as arc AB, which is just write the AB and put the symbol of an arc over top of it. So that's minor arc AB written in symbols AB. We're going to skip semicircle for a second and go down to major arc. So major arc is going to be an arc that has more than 180 degrees. In written words, we can do a major arc as major arc BCA, or with symbols, we could talk about it as arc BCA with that symbol over top of it. If we look at these two different arcs on our picture here, we have arc AB going from A to B, and then we have major arc BCA, so we're starting at B, B, C, A. Now, the order really makes a difference here. So you want to make sure to follow the letters here. Order makes a difference here. So make sure that you're always going through and following the order of those letters. So if I went from from B to A and then to C, that's going to represent a totally different arc within our picture here. Now, a couple of other quick things before we move on here is to remember that the entire circle is equal to 360 degrees. A circle is made up of 360 degrees. So a semicircle, or if we wanted to represent half of that circle, a semicircle or half of the circle has an angle that's equal to 180 degrees. A couple other new terms here are going to be an intercepted arc. And an intercepted arc is going to be each end point of the arc lies on different rays of the angle. And an intercepted arc is going to be where the angle touches the edge of the circle. So for example, if I was to take a look at this angle that's drawn here, which is a special one we'll talk about in a second, but it is intercepting the circle at this point and that point. So therefore, I have this intercepted arc drawn here. Now, if I was to put it in relationship to our previous picture that we had, if we had this circle here, I drew my diameter, my center point O, point B and D, and point A over here. I was to draw in radius OA. I can see here that AB, arc AB, you can see the arc drawn here, arc AB is intercepted by angle AOB. So this angle AOB is intercepting my arc AB. And notice that it is above there, but we'll just draw a little bit clearer. Now, this arc this angle that's drawn over here, this blue one that I've drawn in here, is going to be a special one. And that's because this is representing a fourth of the circle. You can see before I colored it over, there was a 90-degree angle there, which means it is going to be a quadrant. It's an arc that is 1/4 of the circle. So if this is 90 degrees, 90 degrees is going to be equal to a fourth of 360 degrees. So that's representing a quadrant of our circle. The last one we're going to talk about here is going to be a sector. And a sector is going to be a fractional part of the area of the circle. So we can see here that I've shaded in this blue piece. And that blue piece, that shaded section, is going to represent the area of the circle, that specific area of the circle. And that is going to be a sector. When I think of a sector, I'm thinking of a piece of pizza. So think of an actual slice of pizza there. So if this was my circle, there's my center, that is going to be my sector. Let me know if you have any questions.